Yeah, I'll trim stuff, as I need to, the front and the back of it. So it'll be good. All right,
Perfect.
so let's let's start. Hi, and welcome to year 3 of the Trees Around the Globe Student Research Campaign's interview with a scientist and subject matter expert. My name's Brian Campbell, and I'm the lead for the Trees Around the Globe Student Research Campaign. Today, we will be talking to our featured speaker for the December 8th, 2020 Trees Around the Globe Student Research Campaign webinar, Peder Nelson. Let's get started. Hey, Peter, how's it going today?
Great, Brian. How are you?
Excellent, excellent. So, first question here, it's going to be a little background about who you are and what you do. So, first of all, where do you work and what are your primary areas of research?
Well, thank you. I am out here on the western coast of the United States in Oregon, and you can see the type of forests that surround me in this background picture. And so I currently am an instructor of geography and geospatial sciences at Oregon State University in Corvallis, Oregon. And in that capacity, I teach students how to use NASA satellite data as well as other data, geographic data to help answer questions. And in addition to that, I am also a faculty research assistant. And so I help other people doing research. And so I'm currently working on the NASA Globe Observer as the science lead for the land cover tool. So we'll be able to talk all about land cover data, hopefully later on in our presentation together.
Excellent. That's wonderful. So I should also mention that Peter is also the co-lead for the Trees Around the Globe Student Research Campaign. So, okay. So what kind of educational background do you need to get into the career that you're doing right now?
Wow, that's a really good question. So for me, my background really comes from a diverse background in recreation. So learning how to lead people outdoors, learning how to plan a trip, learning how to travel through the landscape is a lot of what I spent my time in my bachelor's degree studying and learning how to interact in that world like that. And from that, I then went on to get my master's degree in environmental education, where I specifically focused on learning how to use remote sensing science and remote sensing data to understand the world around me, to better plan my trips so that I have better experiences when I'm out there. And the people I go out with are well prepared and can understand the environment and the changes. And so I've spent a lot of time learning math, learning physical science, learning natural science, learning chemistry and physics, but also importantly, learning how to communicate with other people. And so I hope I'm doing that well, but that is a big part of the science education and background that I came to this with. And so it's open to anybody. That's the great thing, is that the science has opened up since when I first started doing it. And so now you have the Globe program and other pieces like that that can help facilitate doing the science. So anybody can actually start doing NASA science.
That's wonderful. And that lends itself perfectly to what we're doing in the Trees Around the Globe Student Research Campaign. We're trying to get students and educators to combine the science they learn with the real world. And that's what you've been doing the entire time as you were preparing yourself for the career that you're in right now. So that's
Yeah.
awesome stuff.
And
Yeah.
it's incredible because the opportunities that we have today from NASA, from the National Science Foundation, from the State Department, from NOAA, who all support the Globe program, really facilitates this science. And it's just been an incredible experience to see it change and to actually see it open up so that we can have a Trees Around the Globe campaign like this, where we actually can understand the carbon, the environment around us.
Yeah, that's perfect. So with that said, with your research, with being out, I definitely can tell you're an outside person. You like to be outside, walking around, doing hikes, climbing mountains, things like that. Being in all different types of climates and weather. Okay, and there's a lot of, it's very unique out there in Oregon where you are. I'm in Maryland, so it's completely different. The climate's completely different. The weather's different. Everything's different. So when you're doing that, what type of things do you hope to answer with the research while you're out there, taking observations, taking measurements, for what you do? What types of things do you hope to answer?
Well, for me personally, when I'm out there, I just want to know, what's around me. And so I just have this natural curiosity and question, no matter where I go, what is that tree? How long has it been here? How big is it? How tall is it? How many other people have seen this tree? And so there's a lot of personal questions that I think about as I go out there. I'm also really fortunate that those same questions can be used for science, that other people are asking the same kind of questions. And so we can use the scientific method to record data in a more systematic fashion so that we can actually exchange that information. So other people can use it to manage the trees around me, can figure out where that recreation trail needs to go, for instance. So my personal questions have actually can turn into those professional questions where somebody is willing to actually pay me to help record the height of those trees, or where I can get paid to spend time outside like that. That's kind of the ultimate goal of me, or many of us, is to get paid to be able to answer these questions that we personally are asking while we're out there. But those, we're fortunate. I feel very fortunate that I have the opportunity to spend a lot of time doing this. But these questions about what's around us, how long have they been there, are very personal questions as well, that help to connect me to the place that I live. And they're ones that when I travel, when I'm fortunate enough to travel, I'm able to understand and see the ecology, the landscape different, because I compare it to where I come from. And so Brian, if I was able to travel to Maryland, I'd be comparing it to the trees that are around me, and I'd be doing a comparison contrast the same way that a professional scientist does. But I'd be doing it on a personal level. I'd be always asking that question of, why is that growing there? How tall is it? How long has it been there? And those are just very personal questions that also can be turned into very big science questions.
That's great, because that's one thing that, with the GLOBE program, with people with students and educators, citizen scientists taking observations of trees and land cover and all these different protocols across the planet. They have that ability, even if they can't travel there. There's photos out there, and they can look at these photos and say, hey, what if a height of a tree and a picture of a tree was taken in my location, and then another place, say somewhere in Europe, was taken at the same time. What can I do? Let me look, can I compare these? Can I contrast these? How do I figure out, what's growing here versus what's growing there? And, that's a real great thing about, the science, because, the science is always there, but people taking observations in so many different places really helps us understand.
And it helps us to build our own model. This is
Yeah.
an important thing, that as a human, I build the model of how the world works based off of what I know and what I experience. And the challenge that we have is getting enough information where we can really understand the different types of forests, the different types of ecosystems, the different things that make up this glorious planet that we're all living on. And sometimes it takes years for that experience to percolate through, for it to show itself in your own environment or in your own life. But these are the pieces that we need to build an accurate model, is a lot of observations in our personal life and our professional lives, and a way and a framework and a way of being able to record those observations so that we can go back to them when we really need it. A fire, a flood,
Yeah.
all kinds of events are happening around us that change the world that we're living in. And so one of the challenges that I have as just a human, and as a scientist, is to find a way to record that so that it can be used for future decision making, so that other people can understand not only what I saw, but how they can use that in their own life, and hopefully, in a way that makes the world a little bit better for all of us who are living here.
Yeah. Well, that's a perfect transition into our next question, and that is, how and when did your interest begin for the work and research you are currently doing? I know you mentioned a lot about, earlier in your career, early in your life, you were outside a lot, taking observations, just understanding what's around you. So I'm sure that's part of it, but can you expand on that a little bit?
Yeah. So for me, it was sitting in a college class one day when somebody showed us a satellite picture of where we were sitting. And all of a sudden, all of those experience and things that I had been seeing on the ground, I got a different perspective. I got this broader perspective. And all of a sudden, I could see for miles in a way that I had never before, like a bird,
Yeah.
flying over and looking down at that landscape. It changed my perspective. And all of a sudden, in that moment, I saw my own path forward, the path that I wanted to follow, which was getting that new perspective that very few humans have really been able to do, which is that broad landscape perspective from space. And that's where I'm really fortunate that NASA and other people who came before me set the groundwork, started doing the hard work of putting a satellite up in space so that 20 or 30 years later, I could look at a picture from that satellite and it changes my life. Those people weren't thinking about me. It might have been, but most likely they were just collecting their data, right? But for me, it was transformative to see the place I was at from a very different perspective like that. And so when I saw that was a possibility, that I could actually study Earth from that way, I had a new career path. And so that's when I had to go learn the technological skills. I had to figure out, how do they get a satellite image from space down to my computer or onto my mobile device. And that's when I had to buckle down and put in some hard work to learn how all of this works, how it happens. But it's been really rewarding, because from that, I've actually been able to now time travel using these satellite images. I've been able to invite other people along on this journey and show them something that very few people have really been able to see, which is Earth from space. And we're part of that generation that gets to not only see this, but then to build the infrastructure to help the future generations. And they'll be doing amazing things with all of this information that we can't even think of. And so to be a part of that, was just kind of incredible to think about how just sitting in a classroom one day, it just changed my life. And so that's what one of the things that drives me is wanting to do the same thing for other people, hoping that that satellite image or that information will give them a direction that fuels them for their career, for their life.
Yeah, that speaks volumes. It's so powerful for, inspiring that next generation. And once again, you've transitioned into the final question perfectly. So it's kind of a loaded question, but to inspire that next generation of scientists, engineers, researchers, can you give us maybe just one example of a question related to kind of what you do with land cover and trees that you think Globe student researchers could or should try to answer with their own research?
Yeah, I mean, the most obvious question for me is, are there trees in the area that you live? Just right there. Because if there are trees, well, then you can start asking all kinds of interesting questions about who are they? What genus and species might they be? You can look at the leaf type that's there. You can look at the height that's there. All kinds of interesting questions that come up with, why do the trees look the way they do in my area? Very fundamental question, but recognizing that the trees you see today might not be there in the future, or the trees that you see there today might be very different than the ones that had come previously 200 years ago or 300 years ago, right? And and if there aren't any trees in your area, that all of a sudden opens up another question of, well, why aren't there? What are the limiting factors there that are keeping trees from growing? And I focus on trees in part because they are a long-lived species, and so they get to see things. Here in Oregon, we have some trees that are 800 to 1,000 years old. They have seen a lot, and they have recorded that, in the type of limbs that they have, the structure, the shape, the size. All of those become really, really interesting questions that really just start with that first one. Are there trees in my area? And for me, this relates back to that satellite picture, that satellite image that we get from space. Is the first thing that we see is it green? And how green is it? And that relates right back to the photosynthesis that is happening by those trees, and then the carbon sequestration that is happening in the trunks. And so, what you see is that there's so many questions that it can overwhelm you. And so for me, stepping back and just answering those first questions, are there trees in my area, is a very foundational one, because we have the ability to use the satellite imagery to look back in time for that location, and to be able to also ask that question: has there ever been something green in that area that might indicate that there were trees in the past? And all of this goes back to the carbon cycle, and even the water cycle in our area, and how that is changing. And the scales that are happening, or the processes that are happening out there, sometimes are happening on daily cycles, sometimes they're happening on seasonal cycles, sometimes they're working on decades or centuries. And
Mhm.
so you as a student, or as somebody who's just interested in this world, you can really focus on what's happening today, and how does the sun change through those trees and through that forest. Or you can look at how the season changes in that area. Or you can, if you're lucky enough, you get to see how a whole entire year looks in that area. These, sometimes, science goes back to dedication, and being dedicated enough to go back to a location to repeat those measurements over time can reveal patterns and processes that otherwise are just hidden out there, that might take some more clues or more investigations to figure out. And that's the challenge that we have, which is one reason why we have all of those satellites up in space, is to make it easier for us. So I don't have to go back to the same location all the time. And that actually opens up the type of science that we can do. It opens up our observations, and we can actually understand things in a way that we may not be able to, because I just can't get there, or you can't get there. Right.
Yeah.
And so let's use the NASA assets to fill in those gaps between when we're able to make our observations, or when we're able to get to a location. But together with what we collect on the ground and what we see from space, and with the measurements we see from space, it can really give us a great integrated picture of what is on the surface of the Earth, and the processes that are happening out there.
I think that's a perfect statement to end with, Peter. So thank you so much, Peter, for taking the time to speak to us today. We look forward to hearing more about the trees and land cover at the upcoming webinar, which is Tuesday, December 8th, 2020 at 2:00 p.m. Eastern Time, which is also 7 p.m. UTC. And the webinar is entitled, Peter's featured presentation is called Trees Are Land Cover. So please join us at the webinar to learn more about trees as land cover. And thank you again, Peter, and Take care, everyone.
Thanks. Hope you join us.